Hey guys, so here we go, starting chapter 3. It's about polynomials. So let's just talk about some of the terms that we already know. We already know that monomial means one term. Mono means one. So -9 is a monomial. -3x squared y is a monomial. Z is a monomial. It's just a bunch of terms that are multiplied together. So this would be a -1 times 3 times x times y. All multiplied together gives me one term. So what does a polynomial mean? I think it then follows suit that a polynomial would mean many terms, since poly means many. The definition of degree is the sum of the exponents of the variables. The sum of the exponents of the variables. For example, that term has no variables, so its degree would be 0. This term has 2 x's, 1 y, 3 z's, so that would make this a degree 6. And we'll look at that more in a further page. Leading coefficient is the coefficient of the first term. There are going to be a lot of new terms in this chapter, so either start a Quizlet or make flashcards, but you're going to be referring to them for the rest of the year. There are some things that are definitely not polynomials. So examples of non-polynomials would be having an x in the numerator, having a fraction in the numerator, having an x in the denominator. The absolute value of variables. Absolute value is not considered a polynomial. A square root is not a polynomial. Those are all examples of things that aren't a polynomial. You probably ought to write reasons why these wouldn't be polynomials. So this is an example of a polynomial. Poly mean many terms. Don't forget that terms are separated by addition and subtraction, so this would be a term, this would be a term, this would be a term, this would be a term. So this guy has 4 terms. First thing I need to do is write it in standard form. Standard form writes something with the highest degree down to the lowest degree. And I now know that the highest degree here is this would be 2, this would be 3, this would be 0, this would be 1. So I will rewrite it from highest to lowest. The leading coefficient would be the number in the very front, the line leader, and since that is assumed to be a 1, it would be a 1. And finally, our degree would be the degree of the highest exponents. So this guy gives me the degree right here, so my degree would be 3. Finally, I need to decide whether it's a binomial, which stands for 2 terms, a trinomial, which stands for 3 terms, or a polynomial, which stands for many terms. So anything greater than 3 terms would be a polynomial. This then obviously would be a polynomial. Okay, so not only can we be classifying polynomials by the numbers of terms, but we can also classify by its degree. So let's move down this row. A constant is a degree of 0. Whoops, let's not do highlighter. A constant is a degree of 0, and 5 would be an example of that. You guys know what a linear looks like. A linear has a degree of 0, and that would be 2x minus 5, because the degree right here would be a 1. We've just finished a whole unit on quadratics, and that would be negative 3x squared minus 5x plus 7. That has 3 terms, so that would be a trinomial. A cubic has a degree of 3, and it doesn't have to have all the terms filled in. X cubed minus 7 is a cubic. It would be a cubic binomial. A quartic has a degree of 4, and it would be 7x to the 4th minus 2x cubed plus x plus 10. Notice I'm missing a degree right in here. I'm missing the squared. I don't have to have 4, 3, 2, 1, 0. And the last, obviously, would be quintic. I don't say quintic, it's quintic. And that would be something to the 5th. So negative 2/3 x to the 5th plus x would be an example of a quintic. Again, this would be a monomial, a binomial, a trinomial, a binomial. This would also be a binomial, and this would be a polynomial. The other thing I don't want you to forget is that I can classify these by the number of terms and the degree. So for example, I would call this a quintic binomial. Now let's talk about adding and subtracting polynomials. Let me write 2 examples down real quick. Adding and subtracting polynomials is a lot like, or exactly like, combining like terms, just like we just did with complex numbers. I'm going to combine like terms. I'm not going to do this the entire chapter, but remember, if I have a add in the middle, I cannot multiply over an addition or a subtraction. So parentheses always implied distribution, so don't forget there's an implied 1 here, which I would distribute to all of these terms. I don't need to, because I know multiplying 1 by all of this won't change anything. It will just drop the parentheses. So I get this. And now I just start with the highest degree, and I combine like terms. Well, my highest degree ends up being right here in the middle. So my first term will be x cubed. I now have negative 17 minus 5x squared, so I'm going to have negative 22 x squared. I have negative 13 plus x, so I have negative 12x. And I have negative 5 plus 5, which will give me a 0. And I want to remind you that we can, for sure, check this by putting our question in y1 and our answer in y2 and checking the table. Now I'm going to look at a subtraction. Again, I cannot multiply over the subtraction, so I'm going to distribute the 1 to the first trinomial. And I'm going to distribute a negative 1 to the second trinomial. I will now combine like terms, starting with the biggest degree. My x's will cancel. And again, if I put this one in y1 and this one in y2, my table should match, because this is simplified form of this. Now we're just going to review some terms that we've already learned. These graphs do not need to be on graph paper. I'm going to pause and put graphs on all of these, so give me a sec. The first thing we're going to review is what a function looks like if it's increasing. Remember, a function that's increasing is going from the bottom left to the upper right. This is not going bottom left to upper right. This is decreasing. So I'm going to go through and highlight I am increasing to this point. I'm increasing to this point. Here, I'm increasing to this point. Here, bottom left to upper right, I'm increasing this whole way. And don't forget, these arrows mean that this will keep going. Here, I really start right there, and I'm increasing this entire section of that graph. In this last graph, the only place I'm increasing is there to there. Now, what about decreasing? So let's talk about decreasing. Decreasing goes from upper left to bottom right. So this whole graph is decreasing. I'm decreasing here and here. I'm decreasing here. I'm decreasing, this really looks linear, doesn't it, right here? I mean vertical. This looks vertical, it really shouldn't be because that wouldn't be a function. It really needs to come more out here. That would be decreasing. I'm decreasing here and here. And what does that mean, decreasing? It means if I'm putting in x's all along here, my y is becoming less. But as I cross over right here at this low point and I keep putting in x's, my x's are now getting bigger. So let's talk about this. As I put in x's here, they're getting smaller and smaller and smaller until this point right here, the minimum, the relative minimum, and then all the way over to this relative maximum, they will increase in value, and then they start decreasing again. Last thing I want to look at are zeros. And you know that zeros are anywhere that I cross the x-axis, so there's a zero, there's a zero, this guy has 2 zeros, this guy has 1 0, 1 0, 1, 2 zeros, this guy has 1, 2, 3 zeros. Don't forget that this right here, when it hits and bounces, I call it a bounce, is called a double root. I don't call it a double zero, I call it a double root. Last thing I want to introduce you to real quick is something called Pascal's triangle, and some of you may have seen it. Just want to make sure that I introduce it to you. Pascal's triangle is made out of a pattern of numbers, and at the top would be the number 1. The next row would have 2 1s. The next row, so this is my beginning row, so this is called row 0. The next row, the next row, this would be called row 3. So we have row 1, 2, no, row 0, 1, 2, 3, 4, 5. I will see you tomorrow.